Welcome to the math record. This would be the third part of the ICTM Regional 2020 Division AA Geometry, which I'll be covering questions 13, 14, and 17. Okay, questions 13. The sides of triangle ABC has length 7, 8, 9, and three distinct segments are drawn between the points of trisection of the sides that are closest to each vertex, forming a convex hexagon. Determine the area of the hexagon. So we have a triangle. And then we had trisection points. So a point here, point here. So it's just like a general idea. And then we make a hexagon. So we have a line here, and a line here. That looks fine. So, and then the lengths are 7, 8, and 9. So 7, 8, and 9, it doesn't matter which order. And then basically we need to find the area of this hexagon. So how do we find that hexagon? Well, what's the ratio of this in total triangle is in this hexagon? Well, we know that we split up this line length into a third because that's trisection point. So this is 1/3 of this entire side length, and this side length is 1/3 of this entire side length. So that means this area should be 1/3 of this entire triangle because it's just similar. Because 1/3, 1/3, and that makes the area 1/9. So this is 1/9 of the area. And you can apply the same logic to this triangle and this triangle. So that means this side length is, this area is also 1/9 of the entire triangle, and this is also 1/9 of the entire triangle. So 1/9 plus 1/9 plus 1/9, that's 1/3. That means the area of this triangle is equal to 2/3 of its of the entire big triangle. So how do you get the area of this big triangle? Well, actually, all you have to do is just use Hero's or Heron's formula. So add the three side lengths together, so 7 plus 8 plus 9, and then divide by 2, which you get 12. And then from each of these numbers, subtract from 12. So 12 minus 7 is 5. And then 12 minus 8 is 4. And then 12 minus 9 is 3. And then multiply them together and take the square root, and that will give you your area. So I usually like to find out perfect squares. So I could take the 3 and the 3 here to make a 3, which leaves a 4, which takes with this 4 to make a 4. So we have a 5 still in the radical. So 3 times 4 is 12, square root of 5. And that's the area of our triangle. Now we need to find 2/3 of it to get our hexagon. So 12 square root 5 times 2/3. So that's a 4 times 2 is 8. So that's 8 square root 5. And that's our answer for number 13. Okay. And now number 14. The transformation t given by the equation x prime is equal to negative 9 over 41x plus 40 over 41y and y prime equals 40 over 41x plus 9 over 41y is a reflection across the line L, where the equation of L can be written in the form y equals mx plus b. Determine the sum of the slope of and the y-intercept, basically, so m plus b. So what we could do is that since they already gave us the like graphs of transformation, all we had to do is just kind of find the midpoints between the original point and the transform point, and that should be the line that's in in our reflection line, which is L. So let's just choose a simple point in the beginning. So I know that they're multiplying to some number, and then we add them together because x times negative 9 over 41 and y equals times 40 over 41. So if we want to get a simple solution, we would just use xy, which is 0, 0. So we just use these 2 points. So we put 0, 0 here. That means our x prime, our y prime, which is our transform point, is just equal to 0, and this also is equal to 0, right? So that's a really easy point to choose. So let's choose another point that makes it easier. So let's say x and y is equal to 41 because they're all divided by 41. So we have 41 over 41. So 41, 41. Now if we plug in here, that means our x is just negative 9 plus 40, which is equal to 31. And our y prime is just 40 plus 9, which is 49. Okay, so let's kind of graph this to see how this looks. So something like this. So we have a 0, 0, which transformed to 0, 0. And then we have a point 41, 41. So something like right here. and we have a point that, and it transforms to 31 to 49, so 31 and then 49, so all the way up here. So basically we need to find the midpoint between these 2 points, and then there's a midpoint right there. And then basically a line of reflection is basically going through this um, these 2 points. So we need to find that midpoint. So 41 plus 31, that is equal to 82 divided by, 72 divided by 2 is 36. So our midpoint here, x coordinate is 36. And then 41 plus 49, that's 90. And then 90 divided by 2 is 45. So that's our midpoint between these 2 points, because that's just 31, 49. And this is 41, 41. And this point is 0, 0. So we just need to find the slope here. So 45 minus 30, 45 over 36, because it's just 45 minus 0 and 36 over 0, rise or run. Then so 45 divided by 9 is 5, and 36 divided by 9 is 4. So that's our slope. So y equals 5 over 4x plus some kind of y-intercept. And our y-intercept starts at the origin, so we just plus 0. So so m equals 5 over 4 and b equals 0. So that means our sum is just 5 over 4. And that's our answer for number 14. Okay, so you don't have to like do anything like really extra. All you need to know is you just need to plug it in. So you don't have to like work with these equations to just get into x and y. Okay, now number 17. Points B, A, C, D lie in their respective clockwise order on a circle. Triangle CB, so CBD. So let's just kind of draw a general idea of this before we make some modifications. So we have BAC. So we have, let's just kind of draw this. So let's say B and then A and then C and then D. I usually like to put them equally spaced, and then we can modify them later to adjust for how it kind of looks. And then we have CBD is 50 degrees. So this is 50 degrees. And we have ADB. Okay, so this right here is equal to 8 degrees. And they say BD is the minor arc. So it's this length right here. That's BD. So I'll just put that as BD, arc BD. And let AC be a major arc. So AC major arc, so it's this arc right here. So that is AC, such that each of these two arcs contain whole number of degrees, so they're integers, such that the degree measure of the major arc AC is the integral multiple of the minor arc BD, and such that two arcs have no points of intersection. So looking at our diagram, we see points of intersection, right? It's this big one and then the small one, so it's intersecting right here. So that basically tells us that the AC cannot be here. It actually has to be somewhere else. So the points for A has to be like right here, and the points for C has to be right here, because then our major arc will be this way, while our minor arc will be right here for BD. So then they don't have points of intersection. So we had to modify the circle that way. And we also know that AC, the major arc, is a integral multiple of BD. Okay, so let's kind of redraw this equation, redraw this. So I'm just gonna make this smaller because I had to look at it to modify it. So we have a big circle, and we have B and D, and we have now A and C. Okay, so for this to be a major arc in this direction, basically it tells us that it has, let's say we have like a diameter, right? If this is 180, if both of these points are right here, then the major arc is gonna be this way. But if points are from behind it, right? That means the major arc is this way. So that's why we had to put the points behind this diameter. And that's how I know how I need to know I need to modify this. And then we have A here. So that was just a little justification how I modified it this way. So now we have BDA. So we have BDA is 8 degrees. We know this is 8. And this is just an ascribed angle. So this is half the entire arc. So 8 times 2 is 16. So this is 16 degrees. And then we'll do the same thing for DBC from that one. So this one is 50 degrees. So 50 times 2 is 100. So this is 100. So it's not really draw to scale. And then this is arc BD. And this entire big arc is AC. Okay, so now we have a modified picture and it's a better diagram to see what we need to do. Okay, and they said that AC is a multiple of BD. So let's just say some kind of scaling factor. Let's just call it K times BD. And we also know that since this is a circle, it has to add up to 180. And we also know AC has to be greater than 180, right? Because it's this arc. And we said that if we do a diameter here, kind of it has to go over, it has to be behind it. So this is 180, so this makes it bigger than 180. So this has to be greater than 180. And we know that BD plus 16 plus 100 plus AC is equal to 360. That's the idea of a circle. So BD plus 16 plus 100 plus AC equal 360. Okay, so that is 116. So 360 minus 116 is equal to 244. And we know that AC is KBD. So K, well, BD first plus KBD equals 244. Okay, and we know that these side lengths have to be integers. So let's just shoot out our BD times, and then this is 1 plus K, right? This is shooting out. So this has to be an integer and k has to be an integer because it has to be a scaling factor for integral multiple. So that basically gives us that this integer multiplied by an integer plus an integer is an integer. So integer times integer is 244. So all we had to look for is the factors of 244. So 244 is made up of 1 and 24. So let's just kind of delete this diagram because we don't need this anymore. So it's made up of 1 and 244. And then 2 and 122. Let's see if it's divisible by 3 in our calculator. It's not. Divisible by 4 is 61. So 4 and 61. And this is just 2 times 2 times 63, so there's only 6. Yeah, that's perfect. So these are our only factors here. So if BD is equal to 1, that means K has to equal to 244, which means has to be 243 for K. So is that possible? Well, 243 times 1 is our AC, which is 243. Okay, so we just had to keep track of AC right here. And then we have, if BD is now 244, that means K plus 1 has to be 1. That means K is 0, which is not possible because K can't be 0 because it has to be a scaling factor. And now let's say BD is 2. That means 1 plus K is 122, which is 121. So now K times BD, so 2 times 121, which is 242. And that's AC. And it's greater than 180, so we know that works. And now we have 122 on this side. That means here has to be 2. So 1 plus K equals 2, so K equals 1. So 122 times 1 is equal to our AC, which is 122, which is not possible because it has to be greater than 180. And 122 is less than 180, so that doesn't work. Now let's say BD is 4. So if BD is 4, that means this side has to equal 61. That means this is 60. K has to be 60. 60 times 4 is 240. So that's greater than 180. So that works. And now we can flip that around. So 61, K plus 1 equals 4. So that's a 3 for K. And then 61 times 3 is 183 for AC. Now these are all our combinations that work. So just add them together. So 243 plus 242 plus 240 plus 183. And you should get an answer for number 17 is 908. And that basically covers everything for this year's geometry. Well, thanks for watching, and I'll see you at the next math record.